Hello friends, welcome back to my channel Varteta Learning Platform, and in today's video we are going to discuss about some basics of the file handling in C++. Some basic concepts related to the file handling. So one or two videos we will take to understand the basic concepts related to the file handling, and then we will see some practical examples. So before we go for the file handling, let us first understand few of the important concepts. The very important concept that you must need to understand is the stream. When we talk about the file handling, then first of all, whatever we need to understand is this thing, stream. What is a stream? The simple definition of the stream is flow of data from source to sink. Okay, now we talk about the source. So what is the source? The source is your program. And what is the sink? It can be the standard output or the printer or any file on the disk. So any stream is a flow of data from the source to sink. But how does it flows? So based on the flow of data from one place to the other place, there are two types of file handlings we know famously. Okay, so what are those? So let me just go little bit down. So there are two types of file handling. First is high level file handling, and the second is low level of file handling. Whatever file handling you might be aware using the IOStream class, OStream class or iStream class, all that comes under this high level file handling. So what is the difference between the high level and low level file handling? So before that, let us understand how the data flows from the source to the sink. It is all about the streams. So when we discuss about the file handling, we are discussing about the streams, which is the flow of data, which means we are discussing about the flow of data from one place to the other place. So whenever we talk about the file handling, we are talking about the streams, and streams means the flow of data from one place to the other place. So this source to sink information is not flowing directly. When you are using the high level file handling, in that case, the source to sink information there is no direct flow from source to sink. Then how does it happen? This is the source. Suppose this is your program. And using this program, you are going to write something on your standard output device. Suppose you have written cout, endl, and some statement hello or whatever. You have written this thing. So source is the program where you have written the instruction that what data you need to, what data you want to flow from your program or your source code to this sink, which is the standard output device, which is your screen. Okay, so that screen, the standard output screen, is your sink. Source is your program and the sink is your screen. So what happens that when you write something like this cout, then this data doesn't directly go to the screen from source to screen. You have written this hello world or whatever in your program, then it doesn't go directly to the screen. Rather, there is a buffer. Buffer means a temporary memory area, or you can say a cache. Temporary memory, or you can say a cache. So between source and sink, there is a cache. So whatever you are going to write through this, whatever you want to write through this cout, hello world or whatever, that goes to here in this cache. All that goes to the cache. And once the cache is filled, there is a limit of this cache. Once this cache is filled, automatically whatever this cache is associated with, whatever sink it is associated with, it just dumps or flushes the data to the screen or to the output device. So this is how it works. So there is a limit of this cache. Once this limit is reached, this data will be flown, this data will be redirected to the output device, a standard output device, or whatever stream you have created. By default, when you write this cout, then it refers to the standard output device. So this is how it works. But in case if you want to forcefully flush the buffer, then also in that case you have a function called flush. I think it's capital F, so you can see that. We will see that later on when we will discuss about the different programs. So this flush is basically a function to flush all the data which is there in this buffer to the output device. So from source to screen, or from source to sink, the data doesn't flow directly. There is a buffer in between, and this all arrangement is done by the standard classes that you have been provided. Like if you have to open a file to write, then you open an object of OStream class. If you have to read from some file, then you write like this, iStream object you use. So you create the object of OStream if you want to write something to the file, and you create an object of iStream if you have to write something, read something from the standard or any of the files. Okay, so let us see an example. So in case of iostream, you will create this iostream if you have to open a file. That file will be opened on the hard disk, right? But a buffer will be created, and when you will write something to this file, that content will go to this buffer, and once this buffer is filled, that data will go to this file, the hard disk file. So between the hard disk file and your program is creating a file which is on the hard disk, but in fact this is not directly writing to the hard disk. This is whatever it is writing, this has been maintained by your object, this iostream object. This has been inherited from a class ios, okay, which contains a pointer to the stream buff, which is a stream buffer. So this is the buffer, this is indicated by this buffer. So the iostream class has been inherited, iStream, or you can say the OStream class. iostream means input and output both, but we are talking about the OStream here, using which you can write something on the file. So OStream class has been inherited from the ios class, and ios class has a pointer to stream buffer, and this stream buffer is obviously maintained by the ios class. So when you are writing using the OStream object, then you are not directly writing to this file. Internally, you just create an object of OStream and you just write something. You simply write hi, hello, whatever. You think that you are writing to the file on the hard disk, but in fact, internally, this ios class has all that stream buffer management. So using this pointer to stream buffer, to this buffer, it is writing all the things into this buffer area. Whatever content it has to write on the file, all that content has been written here. And once this area gets filled, once the limit reaches, then all the content gets flushed into the actual file on the hard disk. So this is how it works. This is the example of OStream. Similarly, if you are using the iStream, then iStream class is also inherited from the iOS class. And this iOS class contains the pointer to the stream buff. And this stream buff is basically pointing to a buffer. Okay. And you are using the iStream, or if you want to read something from the file, so you are creating an object of iStream, say iFile, right? And you want to read something from a hard disk file. This is the file on hard disk. This is on hard disk, and you want to read something from here. So the data will not directly come to your program. It will come to this buffer first. And then once you read that data from that buffer, then it will come to you. So once you open the pointer to the file on the hard disk, you think that you are directly reading from that file. But in fact, you are not reading directly from that file. You are reading internally. This iStream object is maintaining this content in this file. First of all, it is transferring the content of this file into this buffer. And once this buffer gets filled, or the or whatever instructions are there to, whatever rules are there to fill this buffer, and whatever rules are there to clean this buffer, based on that, when you read something from that file, this reaches to your object, which is I file. You have created an object of iStream. So you can read the file content this way. So in between the source and the sink, here source is a file and sink is your program. So understand the concept of source and sink. I hope you must have understood this concept of source and sink. And this is all about the high level file handling. So in case of high level file handling, the simple thing which you must need to understand is that there is a buffer in between the source and the sink. This is simply the indication of high level file handling. But in case if you want to do a low level file handling, then what happens? In case of low level file handling, there is no buffer. No buffer means, can you write directly to the file, or can you read directly from the file? The answer is no. So what you need to do? Maintain your own buffer. Okay, so this is low level file handling, where you maintain your own buffer and you read and write, and while reading and writing, you maintain the buffer by yourself between source and sink. So that is known as the low level file handling. We don't have the scope of discussing about this, because in this series of C++ tips and tricks, we just will go through the high level file handling, because this thing is a very specific topic, and until there is a need to do the low level file handling, like if you are creating a very very time efficient or very memory efficient program, or any algorithm that you are implementing which is reading or writing to from or to the hard disk, then only you should do this low level file handling. Otherwise you will not see this low level file handling in normal projects. Okay, so in case if your project has something very specific which needs the low level file handling, then only you will be using this low level file handling. Otherwise you will be using that high level file handling concepts only. So we will discuss about the different programs. We will see the different examples that you can create using these iStream and OStream objects for the file handling. Okay, so that's it for today. And please don't forget to like my video, share my videos, and subscribe my channel. And please press the bell notification icon so that you keep getting the notifications once I upload any of the new video. Thank you.